Hello, let's evaluate this integral 0 to 1 sine of ln of t into t square minus 1 by a ln of t. Right? From here, I equal to integral 0 to 1 t square minus 1 sine of ln of t by ln of t. Right? This looks like sin x by x form, right? Uh, you, you might know this formula, integral minus 1 to 1 e power ikx dk half of will give rise to sin x by x. It's just a simple formula. Then from I equal to integral 0 to 1 t square minus 1, right? Then you can write it as half of integral minus 1 to 1 e power I of, here the x is ln of t, into t dk dt. Fine. Bring this 1 by 2 factor outside. Then integral minus 1 to 1 integral 0 to 1 t square minus 1. Then okay, e power ki, right? This k and this I ln of t dk dt. That is I equal to half into integral minus 1 to 1 integral 0 to 1 t square minus 1 into, this can be written as ln t of ki, right? Then which will sorry, let's write it down here. Then it will be, this part will be e power ln of t whole power k I k. Then you will get this part finally, t power I k dt dk. That is, let's do the calculation. I equal to half of integral minus 1 to 1 integral 0 to 1. This will be 2 power 2 plus ik, right? Then the other will be t power ik. Then dt dk. Button plus I equal to half of integral t power 2 plus ik, right? Minus 1 to, just a minute. Let's, then this will be t power x power n, right? Then 2 plus 1 plus ik. This will be 3 plus ik by 3 plus ik. Not t power ik plus 1 by ik plus 1. Alright, this is, sorry, integration is done, right? This is 0 to 1 dt, which is I equal to half of integral minus 1 to 1. As you can see, if we substitute 1 here, 1 power 3 plus ik, right? It will be 1. If we substitute t equal 0, it will go off. Similarly for the second case, then the remaining part will be 1 by 3 plus ik minus 1 by 1 plus ik. right? Then the next step will be, because there are imaginary terms in the denominator, let's rationalize it first. I mean, multiply and divide by 3 minus ik. Here it will be 3 minus ik by, here it will be 3 minus ik into 3 plus ik. Then it will be 9 plus k square. Similarly, here it will be 1 minus ik by 1 plus k square. Uh, let's do one thing here. Let's evaluate separately the real term and imaginary term, which is integral minus 1 to 1 3 by 9 plus k square minus 1 by 1 plus k square, right? The other term is minus I into, imaginary term is minus I of integral minus 1 to 1 k by 9 plus k square minus of minus plus I k, right? Then it's minus of k by 1 plus k square dk. This real part, assume it as A, this is B. So first evaluate part B, imaginary part, of I, right? That is integral of minus 1 to 1 k by 9 plus k square minus k by 1 plus k square into dk is what, right? This looks like f dash of x by f of x, right? Just multiply here numerator by 2 and divide it by 2, right? Then the formula is 1 by 2 f dash of x by f of x is ln of f of x, right? 9 plus k square minus of ln of 1 plus k square. Integral limits are 1 to 1. As you can see here, because of k square, there is a square for k. If we substitute plus 1 or minus 1, it will be the same. Then by subtracting this, you will get 0. 0 minus 0, right? Which will be 0. That means imaginary part doesn't contribute. That is, b is 0. Then I will be getting contribution only from the real part. Half of minus 1 to 1, 3 by 9 plus k square minus 1 by 1 plus k square into dk. Right? Then I equal to, let's see here, uh, because there is a square term for k here, then it will be symmetric. So then you can write it as 1 by 2 of 2 into integral 0 to 1. It will be easier for simplification. C square minus 1 by 1 plus k square. Right? Finally, these two will go cancelled out. Then this will be 3 will get out. Then it will be 1 by k square plus 3 square. It will be 1 by a into 1 by 3 into tan inverse of k by 3. And integral limits are 0 to 1. This will 1 by 1, right? Tan inverse of k by 1. Integral limits are 0 to 1. That implies 3 will get cancelled. Tan inverse of, it will be tan inverse of 1 by 3, right? K equal to 1, 1 by 3. Minus of tan inverse of 0 is 0. Then this will be tan inverse of 1. Then if you do evaluate this, it will be nearly equal to tan inverse of pi by 4, right? Minus 0.4636, a near value. that is integral 0 to 1 sine of ln of t into t square minus 1 by ln of t dt equal to nearly minus 0.4636.